Hi. So from last class, we already talked about how to use AC method or cross multiply to factor the equation. So in this chapter, we were going to talk about how to factor those special factors. I will basically use two formula. So let's begin. Chapter 6.5, factors the special products. So you might already seen this before, but the first formula I would like to introduce to you is the difference of square. Formula is a squared minus b squared is equals to a plus b times a minus b. Okay, so first example, x squared minus 16 is equals to, look, you can see subtracting two perfect square. So the square root is x and 4. So let me write it in here. Subtracting two perfect square. And the square roots are x and 4. So that means the function can be factored as what? X minus 4 and then x plus 4. Okay? We're basically writing 16 as 4 square so that we can see two perfect square terms, and then we can use our different square, this formula to factor the function. So let me give you another example. So I have 9a squared minus 25b squared. So in here, for 9, you can automatically think about, hey, what square is equal to 9? Because we want the whole term to get square, not like just a to get square. A is like half of the term, not the whole term. The whole term should be 9 times a squared. And then the square only works towards the a, but not to the 9. So that means we can write 9a squared as 3a and then square. When you distribute the square inside, you will find out, hey, this is also equals to 9a squared. Similarly, 25b squared, I can write it as 5b squared. Okay, so as you can see, this is a difference of two perfect square, right? So that means we can apply to our formula. So we will have subtracting two perfect square, and our square root is 3a and 5b. So now we use our difference of square. We have 3a plus 5b, and then 3a, sorry. It's 3a minus 5b times 3a plus 5b. Okay, so in summary, our goal is what? Our goal is to find two perfect square, right? If there's a two perfect square and they're subtracting, so that means we can use our formula a squared minus b squared equals to a plus b times a minus b. Got it? Okay, so now, but really important to be, you should notice that when we're using this formula, is the differences of 2 squared. But what if I see some sum of 2 squared? Does this work? Well, let's take a look. If I have x squared plus 36, well, this is a plus. This is the sum of 2 perfect square because I can write 36 as 6 squared. But our formula requires us that this has to be a subtracting, then we can use the formula. So that means we can use this formula. However, we learned the AC method, right? So maybe we can try to use AC method to solve this equation. Which is x squared plus AC method requires 3 terms. So maybe we can add a term as 0 at 36. If we add 0, so that means you didn't change anything about the equation, but we can manipulate 0 a little bit as 0 times x. Okay, so now we can use our AC method. AC method requires us what? 2 numbers multiply together, get 36, and 2 numbers add them together, get 0. So we have that 1 times 36 equals to 36, but 1 plus 36 is equals to 0, not equals to 0. So that means this doesn't work. Another way is 36, 2 numbers multiply together equals to 36. But if these two add together, it's not equal to 0 because these two is equal to 20. Let's try 3 and 12, which is equal to 36, right? But these add together is not equal to 0. That means 3 and 12 is not the number we're looking for. So if we try 6 and 4, we still have, no, 4 and 9. We still have 36, but 4 plus 9, well, this is equal to 13, still not equal to 0. Well, we keep trying, which is 6 times 6 is equal to 36, but 6 plus 6 is not equal to 0. So that means this one, they can't be factored. That means this is prime, there's no solution for this one, okay? We try all the combination that we have, use AC method, try to factor this part, but it won't work. But now if this, I change it to a subtraction, x squared minus 36, what we can do is we will write the 36 as 6 squared and use our method, which is the differences of the square. We have the square root, which is x and 6. So we can factor it as x plus 6 times x minus 6. Okay. So let me summarize it. For the differences of square, we use the formula a squared minus b squared is equals to a plus b times a minus b. But for the sum of square, which is a squared plus b squared, this one doesn't, they can be factored, right? This is prime to each other. Okay, so now what if I raise up the power a little bit? A to the fourth minus b to the fourth. What you can do is you converted the fourth power to a square by using a squared and then square minus b squared and the 2 squared. Now we find what? The difference of 2 squared. And the square root is what? a squared and b squared, right? That's fine. We can look at this as a whole, and then we applied our differences of square formula to factor this. So we have a squared plus b squared times a squared minus b squared. And then this part, what you can do is what? They can continue to factor. So I have a squared plus b squared times a plus b times a minus b. Because a squared minus b squared is another differences of square. So that means the red part, they can keep factored as the next red part. So notice that the a squared plus b squared is what? Know that. A squared plus b squared. What we just summarized before is they can be factored, they're prime. So that means this is remain what it is. Okay. Okay. So the next formula I want to introduce today is called perfect square, which is a squared plus 2ab plus b squared is equals to a plus b squared. Okay. Example, we have x squared minus 6x plus 9. So we use AC method. We want two numbers multiplied to get 9. And then two numbers that add together to get negative 6. So now we think about negative 3 times negative 3 is equal to 9. And then negative 3 at negative 3 is equal to negative 6. So that means negative 3 is the number that we're looking for. So we have x minus negative 3 times x minus negative 3. And since these two terms are the same, so that means I can write it as x minus 3 to square. So if you skip the middle part, so let me cross the middle part. If you skip that part, you will find out that, hey, what we use is the formula perfect square, whereas our a is equal to x, b is equal to our 3. Okay? Which is, I can write it as what? X squared plus 2 times a times b, because 6x is equals to what? 2 times x times 3, and then plus 3 squared, which is our b squared. So if we use that formula, we can get to the answer, which is x minus 3 squared. Okay, so the next would be 4x squared plus 20xy plus 25y squared. Okay, so now we need to convert each term to fit in our a squared plus 2ab plus b squared. Then we can apply to our formula. So 4x squared, I can write it as 2x squared plus 2 times 2x. What's remain? 20xy divided by 4x is equal to what? 5y, which is happen to be our third term's square root, which is 5y squared. Okay, so that means what? This is our a squared plus 2 times a times b plus our b squared, right? So now we can use our formula, which is equals to a plus b squared. Look, this is our a, this is our b. Okay? So for the subtraction, it's the same. So for subtraction, we have what? A squared minus 2ab plus b squared equals to a minus b squared. So they just change the sign for the second term. Here, if this is subtraction, here would be subtraction, but they don't change the sign of the third term. The third term is always plus b squared. Okay, so now we already learned this, the perfect square, and then I want to talk about the sum. Another formula would be the sum of cubes, which is a cubed plus b cubed is equals to a plus b times a squared minus ab plus b squared. And then a cubed minus b cubed is equals to a minus b, and then a squared plus ab plus b squared. Okay, so for the next example, I have m to the cube minus 27. So the first step is we want to convert 23 into some terms of cube. So 23 is equal to 3 to the cube, which is 3 times 3 is 9, 9 times 3 is 27. And now we can apply our formula, the sum of cube, which is m minus 3 times m squared plus 3m plus 3 squared, which is what? Plus 9. Okay, so there is a formula to memorize. I mean, there's a saying to memorize the sign in here. So look, if this is subtract, this part subtract, this one is add, and then add. So the way they memorize it is they use SOAP. What's that mean? SOAP stands for same, opposite, and then always positive. Look, if here is subtraction, the first sign would be what? Same, which is subtraction. And then the second sign would be opposite, which is plus. And then the third term, the third sign would be always positive. This is similar to addition. If the sign is positive in here, right? Add. So the first sign is what? The same. So it's add. So the second sign would be opposite, right? Which is negative. And then positive, that means it's always positive, the third term. So try it by yourself. Look, if I have m to the cube minus 27, we use the same example. We have m to the cube minus 3 cubed. Now we know that the first is m, 3, and then m squared, 3m, and then 3 squared. Okay, now let's fill in all the blanks. So SOAP, same, which is subtraction, opposite, plus, always positive. So here we are. Here's the solution. Okay, so I have 125p to the cube plus 8r cubed. Okay, so now we want to turn these two terms into some cubic root term, which is 5 times p to the cube plus 2r to the cube. And then I have the 5p, 2r, and then 5p squared and then 5p times 2r, and then 2r squared. Now I use SOAP to fill in the terms. So for SOAP, the first term should be what? This is at. So same will be at. Opposite, subtract, always positive, plus. And then we should simplify it. So we have what? 5p at 2r times 25p squared minus 10pr plus 4r squared. Okay? So now let me recap how many formulas that we learned. We totally learned actually it's 3 formulas, but we can expand it the sum of the cube as positive and negative sign, and then the perfect square one as a positive and negative sign, right? So let me recap. So the first one is the differences of square. The differences of square is always differences. They don't have the sum of square. If the sum of square, we just prove it, it will be prime. And then we have let me write this down for you as well. If we have the sum of square, what happened is this is become prime, so that means they can be factored. So the next one is perfect square, which is a square plus b squared a squared plus 2ab plus b squared is equals to a plus b squared. If we use subtraction, it will be the same, which is a squared minus 2ab plus b squared equals to a minus b squared. And then we also learn the sum of cube, which is a to the cube plus b to the cube is equals to a, b, a squared, ab, and then b squared. We use SOAP to fill in the sign, which is same, opposite, always positive. Well, we can expand it to subtraction. Again, we use SOAP to fill in the sign. Same, opposite, always positive. Okay, so now take a look. 7 to x squared minus 2. So look at here. You will think, hey, we can use, since this is 2 term, we can use the differences of square, which is our first formula. But look at 2. 2 is not a perfect square, right? So I can find the square root of 2. I mean, we had square root 2. But the easy way to do it is, you notice that, hey, the first term and second term, they have the common factor, which is 2. So that means we can factor the 2r with 36x squared minus 1. So when it comes to here, we will find out, hey, at this point, this 2 part is what? The differences of 2 squared. Whereas the square root is, the square roots are 6x and 1. So that means that parentheses we can factor as 6x plus 1 times 6x minus 1. So what did this tell you? This one tell you is always find the greatest common factor first. And then you can continue to do the factor, such as this example. 128 a to the fourth b to the second power plus 54 a times b to the fifth. What's the common factor? Well, we already learned how to use common factor last week. So the greatest common factor in this equation is 2ab squared. So I have a 2ab, I factor this part out, I have 54a to the cube plus 27b to the cube. Okay, when you see the cube, what you will use? You will think about the sum of the cube, this one, right? So first step is I should turn 54 into some terms of cube and 27 into some terms of cube. So I have 54, I can write it as 4 cube, because 4 times 4 is equal to 16, 16 times 4 is 54, which is 4 cube is equals to 54. And then plus 3b to the cube. And now they have the cube roots. The cube roots are what? 4a and 3b. So that we can factor it as 4a, 3b, and then 4a squared, 4a, 3b, and then 3b squared. Okay, use soap. Same, opposites, always positive. And now we simplify it. 4a squared is 16a squared minus 12ab plus 9b squared. So that would be the solution. I want you to simplify to this step. Okay? So one thing that I want you to be careful about is when you try to factor the cubic terms, you need to put the parentheses for each term. If you don't put the parentheses, you may end up to be, look at this, 3b, and then you will have 4a squared minus 4a times 3b, and then 3b squared. So instead of, look at here, this part, you want the square to the whole thing, not just a. Similarly here, if you forgot to put the parentheses, what happened is the square only towards to the b, which means you will get to the wrong answer. So the way to solve it is you always put the parentheses for each cubic root term. Okay, so that's it for 6.4. I just uploaded the exam or the quizzes on the Canvas. You should be able to take it today. You totally have 20 minutes to take the quiz, and then you have 5 minutes to upload your answer. And make sure that you will upload the answer to Canvas. Don't email me about your answer because I need to document it every quizzes that you have. Okay, if you have any question or problem, please email me. And also, the due of the quizzes is today. Don't turn in late. If you turn in late, I'm not going to, because this is already our 3rd quizzes, because I give you a mock test to practice, and then you already did your first quizzes. You already know what to do. So I'm not going to let you retake the quizzes or take a makeup quizzes if you miss the due date. So be careful about that. So that's it for today.